Now let's talk about dot plots. These are just another way of organizing data. So we draw a dot plot by placing each observation horizontally in increasing order and placing a dot above the observation each time it's observed, where each dot is the same size. And of course, it'll be as close to the same size as we can get it since we're writing it by hand. So first you write on the horizontal axis each individual observed value, but just once. So if you have 13 and it happens more than once, you only have to put it on the axis once. Then for each observation, you put a dot above the observed value. So let's look at an example. Here we have the number of arrivals at Wendy's during a 15-minute interval period at lunchtime. So you can see we have data values ranging from a minimum of 1 to a maximum of 11. So we put 1, 2, 3, all the way up to 11 on the axis. Then we count the number of observations in each category. So we have 1, 1, so we put 1 dot. We have 1, 2, 3, 4, 5, 6 twos. So above the 2, we make 6 dots. And they should all be approximately the same size. I know that's hard when you're doing it by hand. Okay, we continue on with the 3s. There's only 1 3, so we put a dot over the 3. And you should pause the video and try to see if you can get the rest of these on your own, and then restart the video. So I get that there are 4 4s. There are 7 5s. There are 11 6s. Five 7s, 2 8s, 2 9s, no 10s, and 1 11. So our dot plot should look like what we have here. Now you'll notice a dot plot also looks a lot like a histogram. So that's another reason why it's useful. It tells us how many of each data value we have, in addition to us being able to see the relative frequencies, more or less, of each one. Let's talk quickly now about the shape of different distributions. So a uniform distribution looks like this example here, and the frequency of each variable is evenly spread across all values of the variable. So what does that mean in all practicality? It means every bar in the histogram is approximately the same height. So there can be a little variation like we have here, but by and large, those are all evenly, like they're all the same height. Okay, in a bell-shaped distribution, also called a symmetric distribution, the highest frequency occurs in the middle, and the frequencies tail off to the left and right of the middle. So if we scroll down, you'll see how one of those looks. So you notice the highest point is close to the middle. And then on either side here, where the frequencies get shorter, that's what we call the tails. So the one on the right side is the right tail, and the one on the left side is the left tail. The reason we call these symmetric is because if we were to draw a line right down the middle and fold the paper along that dotted line, the right side and the left side should pretty much match up. So that's why we say it's symmetric. So in a skewed right distribution, the longer tail extends to the right, and so the tail on the right of the peak is longer than the tail to the left. So you can see here, our left tail is from that dotted line that way. So that area is the left tail. And the right tail is very much longer than the left tail. So this one is skewed right. So obviously then, skewed left is exactly the opposite. So the longer tail extends left, which means that the tail to the left of the peak being the highest points, the left tail is much longer than the right tail. Okay, it is extremely important to know that we do not describe qualitative data with these shapes. So these shapes are only used for quantitative data, so data that can be numbers. Okay, so let's look at an example. What would you say the shape of this distribution is? Well, if we look at it, it has a peak, And the peak is pretty much in the middle. And it looks like from either side that both tails here are approximately the same length. So that makes this one normal or symmetric. Symmetric's another word. The other word we use for normal is a bell-shaped curve. You can't really see it here, but these things look like this. And if we make a histogram under there, you can see approximately what a bell-shaped histogram looks like, or a normal histogram. Of course, that would look even better if I could draw better. So that's it for section 2.2, and we'll pick up with 2.3 in the next video.